binomial is of the form a plus b and bracket raised to the power n, where n is a natural number. Now, when we talk about natural numbers, we're referring to counting numbers such as 1, 2, 3, 4, 5, and so on. Now, let's see how we could apply this in expanding binomials. To be able to successfully do this, we must apply what we call Pascal's triangle. This is A. Now, how do we do this? Pascal's triangle is of this form. This is 1. You begin with 1, 1 again, and you start with 1. Add this 1 plus 1 is 2, and you end with 1. You always begin with 1 and ends with 1. You add the numbers in between 1 plus 2, 3, 2 plus 1, 3, then you end with 1. You begin with 1 again, and see the way I'm adding them. It should be at the middle. 1 plus 3, 4, 3 plus 3, 6, 3 plus 1, 4. Then you end with 1. You begin with 1 again. You add these numbers. 1 plus 4, 5, 4 plus 6, 10, 6 plus 4, 10, 4 plus 1, 5, and you end with 1. Continue again. You start with 1. You add the numbers. 5, 1 plus 5, 6, 5 plus 10, 15, 10 plus 10, 20, 10 plus 5, 15, 5 plus 1, 6, and you end with 1. Now that's how you're going to continue the process as you solve on. Now, what does this tell you? This tells you that for the first one, let's start with the very first one, which is 1. It tells you is power 0 coefficient. The next one tells you it is power 1 coefficient. And then the next one tells you it is power 2 coefficient. The next one tells you it is power 3 coefficient. The next one tells you it is power 4 coefficient. And the next one tells you it is power 5 coefficient. And of course, the last one you have there is power 6 coefficient. We'll decide to stop it at power 6, but you can continue and you get power 7, 8, 9, 10, 11, 12, and so on. Now let's assume the question asks us to expand. Expand the following. Let's say number 1, I have a plus b raised to power 0. To expand these, it means I had to look at the power. Now, when the power is 0, the coefficient, it's 1. So everything here raised to power 0 will be 1. That's it. Let's go to number 2. A plus b raised to power 1. I go to my Pascal triangle. If it is power 1, the coefficient will be 1, 1. It means a will have 1 as its coefficient, and b will have 1 as its coefficient. But in mathematics, we don't write the coefficient when it's 1. So we just simply say a plus b. Let's try the next one, number 3. If I have a plus b raised to power 2, now I go to my Pascal triangle. When the power is 2, these are the coefficients I'm going to have. So how am I going to do it? It's going to be like this. A raised to power 2, because the power is 2, and b raised to the power 0. You start from 0. Now, what is the coefficient for this one? We'll come to it later so that we don't get confused. Plus a raised to the power 1, b raised to the power 1, plus a raised to the power 0, and b raised to the power 2. So you stop there. So once you get the power, you stop there. So for the first letter, you begin with the power. For the second letter, you end with the power, the same power. At this point, you can now put in their coefficient. So when it is power 2, these are their coefficients, 1, 2, 1. So the coefficient here will be 1, the coefficient here will be 2, the coefficient here will be 1. But remember, we don't write it, so we'll have to simplify further to get a better result. Here is going to be a raised to power 2. Now remember, this is b raised to power 0, and b raised to power 0 is 1, so there's no point writing it. Plus 2ab, there's no need to put a 1, 1, and this is b squared. So here, this is a raised to power 0 is 1, so there's no point writing it. Now, did you notice something in the expansion? That the powers of a keep reducing as you're moving. Why the a powers are reducing, what happens to the b powers? They are increasing. That's one way to get to know that what you're doing is correct. Now let's try another one. This time around, I'm working with a plus b raised to power 3. Now let's see what we're going to get. Same format. Because the power is 3, I'm going to start with 3. So a raised to power 3. B raised to power 0. So that's how you start. Plus a raised to power 2. So the a is decreasing, the b will be increasing, b raised to power 1. Plus a raised to power 1, b raised to power 2. Plus a raised to power 0, b raised to power 3. When you get to that point, you stop. Now put in the coefficient. Power 3, the coefficients are 1, 3, 3, 1. So the first one will be 1, the second one will be 3, the third will be 3, the last will be 1. So we can simplify this further to be a raised to power 3. There's no point writing the 1. B raised to power 0 is 1, so you're having it this way. 3 a raised to power 2b plus 3a b raised to power 2 plus b raised to power 3. So that is the solution to the question. Well, it's becoming easier, right? Let's try another one. This is number 5. I'm going to expand to the power of 4. So what do? Same thing we've been doing. When it is power 4, I'm going to start with 4. A raised to power 4. And then you start with b raised to power 0. You keep writing, decreasing the 8. It becomes 3. B will increase to 1. Plus a will reduce to 2. And b will increase to 2. Plus a raised to power 1. B raised to power 3. And take one more step. Plus a raised to power 0. B raised to power 4. So if I were you, I'm going to check if what I've done is correct. A4, A3, A2, A1, A0. That's correct. B0, B1, B2, B3, B4. So it shows I'm correct. Now I'm going to take the coefficient for this expansion by going to Pascal triangle, power 4. Now when it is having 4 as its power, these are the coefficients. 1, 4, 6, 4, 1. So let's write it there. 1, 4, 6, 4, 1. So we can simplify this to make it neat. A raised to power 4 plus 4 a raised to power 3b plus 6a raised to power 2 b raised to power 2 plus 4 ab raised to power 3 n plus b raised to power 4. So this is how to expand binomials.